and just kind of looking at some other, parts of it, of how you can go about doing the graphing. We had kind of talked about some different examples. So let's continue with that. So we were at, the transformations. We had the amplitude and the period that we talked about, which were your A and B variables in this general form. And then we had also talked about C, which was your horizontal um, shift that we were looking at. And then, of course, we had your D movements, which would be the vertical shift. So we have looked at, trying to get to the page that we were at. Yeah, so we had talked about this phase shift also, horizontal translation, vertical translation. So we were kind of right about here when we had ended last time. Okay, so this is where we had left off at. We had the last example we had done was number 22. So I wanted to pick up with number 28. So 22 was, this example where we had to describe how the shift and the changes were happening. So let's look at 28 over here. And your instructions are basically saying, sketch the graphs for both F and G in the same coordinate plane and include 2 full periods. So here's number 28 over here. So the first thing I want to do is, before we get to the sketching of the graph, is identify what our A, B, C, and D values are. So that would be the amplitude, the B value to help us come up with the period, the C, and the D value. So take a minute and tell me what each one of these values are going to be. And of course, that's going to be for the G function, because as you can see, for the F function, your A value is going to be 1. Your B value is also going to be 1. And then we actually don't have any C or D values. So this is for the f of x function, which is your original cosine function. And then for the g of x, what do you think? And if it helps to identify your, where is our general form? Right over here. We're kind of talking about this function. Okay, so Abdulaziz, you've got A equals 1, B equals 1, C equals negative pi, and D equals 0. What do you guys think? Do you agree with his answers? Anything you would like to change? Okay, so you are saying C should be positive pi, Abdulaziz, instead of negative, okay? So should I take your silence as you agree with Abdulaziz's answers? Yeah. Okay. Let's write down the general form. So you've got A times cosine of bx minus c plus the b. Okay, just wanted to make sure I had the right signs in there. Okay, so your A value is the coefficient that's multiplied in front of the cosine. So of course, since you don't see any number there, it's understood to be 1, which is kind of the same thing we did with the basic cosine function. So yes, your a value is going to be 1. The b is the coefficient that gets multiplied with the variable c. So again, in both of these functions, also that number is going to be 1. So that looks good. The c value comes from whatever is being added or subtracted. Oh no, 28, Abdul Aziz. So since you have a negative in the general definition and you have a positive over here, that means technically you have x minus negative pi halves. So your c value is actually going to be negative pi halves. And there's nothing being added or subtracted, in the front or the end of our cosine function. So yeah, your d value is going to be 0. So, these guys were obviously non-existent, so they were 0. Also, so that's the first thing, we need to start by identifying is what variables are given to us and what they represent. So again, remember with our a and b functions is where your amplitude and period comes from. So the amplitude is just absolute value of a. When we are calculating the period for our function, you use this little formula of 2 pi divided by b. So that's the first thing we're going to go ahead and do here. So, of course, this tells us that the amplitude for both functions actually is going to be, absolute value of a, which is going to be 1. So that's going to be the same for both of them. Will the period be different between the two functions, or will it be the same? Which was, 2 pi over b. Same, yeah, because your b value is the same for both functions, right? Both of them are 1. So our period is going to be 2 pi divided by 1. So that's 2 pi. Oops. So that's going to be the same for both of them. But the one thing that's going to be different is going to be that shift over here, right? Because our c value is negative pi half. So that was the next thing we had talked about. Trying to find where did we have that. Oh. It's really hard to see with all this writing overlapping here, but I think this is where I skipped over it. Yeah, there we go. Okay, I'm going to try and move this downward. So this is where, we're kind of looking at this form of our equation over here. So remember, we have to talk about how the interval will shift based on this, phase shift happening here. So you have to do your little equations over here. Bx minus c equals 0 and bx minus c equals 2 pi. So we can basically find out, with that phase shift happening, where is our interval basically going to end up with, what that interval, period is going to end up looking like. So let's talk about that next over here. So we are actually going to take our parentheses part, which is given to us as x plus pi halves, and you're going to set that to 0, and x plus pi halves equal to 2 pi. And what will that end up giving us? So what will our, interval period end up looking like? So you're basically solving them like equations and trying to get x by itself. Okay, let me see what you got. Okay, Katie, you've got negative pi halves and positive 5 pi over 2. Up to Aziz, you've got negative pi halves and 3 pi over 4. Okay, so there's a little bit of a difference between the two answers. This one over here, definitely, you just go ahead and subtract your negative pi halves and move it to the right-hand side. So this guy will become negative pi halves. So this will definitely be the, the left endpoint. And then to simplify for the right endpoint, same thing, we would still need to go ahead and move this. Okay, Abdulaziz, I see you're changing your answer to 3 pi over 2, okay? And Katie, you are also going back to 3 pi over 2. Okay, so same thing, guys, move it pi halves to the right-hand side. So you will actually end up with 2 pi minus pi halves. And then, of course, you're solving fractions in a way. So find a common denominator. You would multiply this guy by 2. You would end up with 4 pi over 2 minus pi over 2. 4 minus pi, of course, gives you 3 pi over 2. So yeah, very good. Good job, guys, for fixing your answer. So your left-hand point, you're going from negative pi halves. Right-hand point will be going to positive 3 pi half. So let's go ahead and save this information. And let me write this down before I clear it out so that I will have this information with us. Okay, so number 28, and this is specifically for the g of x function, our amplitude. There we go. Amplitude is going to be 1. The period was 2 pi over b, so that was 2 pi over 1, which was 1. And then our b of x minus c, which I guess I really need to write that. X plus pi halves, x plus pi halves is 2 pi, ended up giving us negative pi halves and 3 pi halves. All right, so that's the basic information we have gathered from our equation over here, which was g of x equals sine of x plus.
Should the period be 2 pi instead of 1?
Oh yeah, thank you. I don't know why I did that. Thank you.
I just want to make sure I
Alrighty.
didn't.
I think just trying to rush through and get it done. So I'm actually going to do our little coordinate plane over here. I'm not sure why it's showing up as purple, but we'll leave it as that. Okay, so remember they're asking us to graph both the original function and the g of x function. So the idea is, you can do a little comparison, kind of like what we were looking at with these functions over here. So I'm not going to spend too much time on the cosine function since we did talk about that last time. So, you can use just this guy as your guide to help you, graph the basic function. So remember how I had pointed out last time with the sine function, you actually start at the origin 0, 0, but whereas with the cosine function, we're not at the origin, we actually start at a maximum point. So you can use this to guide you through the process. Now, since our period was the same, these x values will also be same for both our f and g function. So you can actually use this as your guide again for the x-axis. So we can do, of course, you start at 0, 0, but then you will have pi halves. And the way you can think of this is you're going from 1/2 pi, right? Because the numerator is 1. So this should be technically be 2 pi over 2, which the 2's cancel out, give you pi. The next one should be 3 pi over 2. This guy here should be 4 pi over 2, which would simplify into 2 pi. So you basically go, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and that pattern will continue along the x-axis. Same thing on the negative side. So you will have negative pi halves. So that's technically negative 1 pi over 2. Then again, you have negative 2 pi over 2, which will obviously just end up becoming negative pi. You will have negative 3 pi over 2. And of course, the last one that we need is going to be negative 4 pi over 2, or basically it simplifies into negative 2 pi. Another thing you will notice over here is they tell you to include 2 full periods. So since the period for our function is 2 pi, that means you need to do this over a distance of 4 pi. So you can go from 0 to 4 pi on the right-hand side, or normally I go from negative 2 pi to positive 2 pi, so we can see on both sides of the x-axis what our function will look like. So let's do our cosine function, the base function first. So you can have your positive 1 and negative 1 for the amplitude. And remember, your cosine function starts at a maximum. You go from a maximum to intercept, intercept to minimum, minimum to intercept, and then you end back up at a maximum. So that will be reversed on the left-hand side. So since this is a maximum at the 0, 1 point, when we get to negative pi halves, you will be at intercept. At negative pi will be a minimum, intercept, and then at negative 2 pi, you will have a maximum. So if you draw your little, wave, this is going to be our base cosine function, or if you want to call it f of x, which is what the textbook is calling it. So this can kind of be a guide. Now look at our function over here. We are starting at negative pi halves. So what that actually tells us is that at negative pi halves is where we are actually going to have our maximum, because remember the cosine function goes from maximum to intercept to minimum back again to the intercept, and then it ends up at a maximum again. So for the shift that has happened, instead of starting at 0, 1, like we did with the original cosine function, your maximum is going to be at this left endpoint. So you will be at negative pi halves, which is going to be, this point over here. So this will be at maximum. So that actually tells you at 0, you will be at intercept, which means at positive pi halves. And I didn't write this out well, but you should be at a minimum at positive pi halves, which means it will put us at an intercept at pi. And of course, then it brings you back up to a maximum at positive 3 pi. Does that make sense to you how the shift happened? Because, since you did the positive pi halves, your graph moved to the left. So imagine that graph in the black is moving just by that phase of pi halves to the left. So each of these points are basically moving to the left. Okay, that's kind of what's happening over here, but I'm going to get rid of those arrows. And you can continue that pattern. So if you are at a maximum at 3 pi halves, that means at 2 pi, you will actually be back at an intercept. On the left-hand side, at negative pi halves, we have a maximum, which means at negative pi, we'll have an intercept. At negative 3 pi halves, we will be at a minimum, which will actually bring us back to the intercept at negative 2 pi. So then you can go ahead and draw these curves. And the one in the red is your g of x function of cosine of x plus pi x. And I know I'm kind of, going step by, not kind of breaking it down step by step, but, we did talk about our A, B, C, and D values, so we knew what kind of change was happening. And I really like this key point kind of breakdown. So, always looking at the cosine or sine function, you would know where your starting point is. Cosine begins with a maximum, but the sine function, will always begin with the minimum. Does it show that to us here? Yeah, sorry, intercept. The sine function always begins with an intercept. So, once you find that period interval, use that to come up with your ordered pairs, based on your amplitude. Now, since we knew the amplitude of our function was 1, we knew our maximum value had to be at +1 and -1. So, that would guide us. So when we are talking about maximum, if you had to write this as an ordered pair, this would be at +1. Our intercept would be at 0. Minimum would be at -1. Intercept is back again at 0. And then this last maximum would, again, bring us to +1. So you're letting that amplitude guide you on what your maximum, intercept, and minimum y values are going to be. However, keep in mind, guys, if our graph moves vertically up or down, then you just cannot use the amplitude. You have to use the amplitude along with by how many units is our graph moving up and down. So that would come from that D variable. But right now, since our D variable was 0, we don't have to worry about that vertical translation. And so we can just use the amplitude to tell us, where those y coordinates for these points are going to be. So some of this will take a little bit of, practice, just kind of getting used to graphing these functions, especially since your x values are not the traditional, we kind of like or decimals, dealing with these pi halves and pi's and -3 half and all of that. But basically, you can see how each one of these guide us. Now, like I said, your period is going to pi. So since they're asking us to graph 2 periods, we did this from negative to +2 pi. And then, of course, our horizontal shift also gave us an idea of where we needed to go. Let's see, did they want us to do anything else? No, they just want to do this. So any questions that on this example? Now, even though you guys are not graphing by hand, you will still need to recognize how these transformations are happening. So do keep that in mind as you look through your homework examples, because even though you don't graph by hand, you still have to choose the right graph. So I would suggest, draw a rough sketch so at least you know what the correct graph should look like. So questions? And, of course, if they had to describe the shift, you would talk about a horizontal shift. We would say you are, doing a horizontal shift by pi½ units to the left, which takes care of that negative sign on the pi halves. Alrighty, very good. So that was number 28. Number 38 is also talking about graphing. And this one is actually with a sine function. And this one is a little bit different because you can see you have that pi/4 on your x value. So I will ask you the same thing here. Can you identify your A, B, C, and D values first? And if it helps, let me put down that general equation. And since this is a sine function, we'll use sine over here. You know, I would like all of you to participate, because if you don't participate, then I don't know if any of this is making sense to you or not. So, you know, either just unmute yourself and give me the answer, or try putting something in chat so that way I know, you know, you guys are on the right page with me. Okay, so Abdulaziz, you've got a equals 1. And that would be the coefficient in front of sine. So very good, that will be 1. Why is your b just 1/4? Khalid, you've got b equals 8. A equals 1, that looks good. C and D, yeah, because you're not adding anything, you know, over here. So C value is going to be 0. There's nothing being added or subtracted in the front. So the D value is definitely 0. So C and D looks good, and looks like you guys are doing okay on the A value. I'm not happy with your B value though. So let's see, Alicia, you've got B equals 8. Jack, you gave me pi. Khalid, you also had 8 for the B value. And Abdul Aziz, you had 1/4. Anybody else want to give it a try? Look at the general equation over here. How are we defining the B value over here? And how would you use that, you know, in this function? Eusebia, you also had pi. Oh, come on. Somebody's got to realize what the answer is. Katie, I will give it to you. You are close. All righty. So your B value is going to be everything that is not X on that coefficient. So your B is going to be a combination of kind of what you guys were coming up with. And I have a feeling I know where you are getting the 8 from. The 8 is the period, not the B value, right? Because for the period, you have to calculate 2 pi over B. So we're not quite at that point yet. You're just identifying what's the coefficient on X, basically, right? That's the pi over 4. All right, so of course the A value, again, will give us the amplitude. So we know that's going to be absolute value of 1, which comes out to be 1. Your period for the function comes from the 2 pi over B. So that will be 2 pi divided by pi over 4. So since you have a fraction on the bottom, remember, you can write this as 2 pi times and then invert the fraction on the bottom and rewrite it as 4 over pi. So, you know, if it helps, you can put this guy over 1. So what's going to happen over here then, we have a pi on the numerator, pi on the denominator. They will cancel each other out. And you are left with basically 2 times 4, which will give you 8. So is that what you guys did when you came up with B equals 8 as your answer? You basically solved for the period? Yeah? Okay. So just, yeah, kind of recognize that there is a difference between just recognizing what the B value is and then calculating your period for the function. Alrighty, so you can see how the period for our sine function over here has changed, because remember the basic sine of x function has a period of 2 pi. And you know, if you plug in 2 pi into your calculator, you will get, what is it, 6.28 something? What is 6 times pi? Sorry, 2 times pi. Yeah, 6.28. So you can see this period is just a little bit longer than that, since we got a period of 8 units over here. So let's see what this graph will end up looking like. So again, let me go ahead and transfer this information to our page over here. This guy was what, 38? Y equals sine of pi x over 4. We have amplitude 1. Period is 2 pi over b, so that's going to be pi fourth, which came out to be 8. Okay, let's talk about period interval. So let's get rid of this stuff here. I think we've got everything from here. So how do you think we can calculate our period interval, kind of like we did in the previous example, where you used bx minus c equal to 0 and bx minus c equals 2 pi. How will you translate that for this function? What's our bx minus c for this example?
Would it be pi fourth minus 0?
Very nice. You don't have the c part, right? But we still have the bx part of it because our c was, of course, 0. So what you will do is just take that, like Scotty mentioned, pi x over 4, and, set them equal to our numbers over here, except the difference here is going to be, let's see, pi x over 4 equals 0. And the other one is going to be pi x over 4 equals, because this should be 8, right? That's our period. Let me see. Or should it still be 2 pi? Give me just 1 second here. No, it will still be 2 pi. Sorry about that, guys. Yeah, it will still be 2 pi. I don't know. I get confused with that every single time. So solve this. Same thing. Get x by itself, and what do you get? So for that left end point, what are you coming up with? Pi x over 4 equals 0. Okay. Okay, Abdulaziz, your interval was 0, 8. Katie, you have 0. Yeah, because you can see, when we invert this fraction and multiply it to both sides of our equation, you would have, 4 over pi being multiplied on both sides so that it can cancel out here. But 0 times anything, obviously still is going to give you 0. So yeah, very nice. Your left hand point is going to be 0. And then what did you guys have for the right? So Billy, you also have 0, 8. All right, so let's take a look at that right hand side. So to solve this guy, same thing, we would still have to get rid of this fraction because it's being multiplied into x. So to get rid of it, you can invert it and make it 4 over pi, multiply on both sides. And you will see that right-hand side calculation looks very similar to what we had done with the period calculation. So you're left with x over here. You know, the pi will cancel out. 4 times 2 is 8. So period interval is going from 0 to 8. Now remember, we have to divide this period interval into 4 equal parts, which means we have to come up with that 5 number summary. And we had talked about that also last time very briefly, right over here. So you can see in this little box over here, we're saying in general, to divide your period interval into 4 equal parts, successively add period divided by 4, starting with the left end point of your interval. So since you're breaking up into 4 equal parts, you know, whatever your period came out to be, which in our case, that number is 8, you are going to start by taking 8 divided by 4, which, you know, of course, comes out to be 2 in our case, and start that by, what did they say? Start with the left end point of the interval. So we're going to start with 0, 8 over here. So you're basically taking 0 is going to be your, is that going to be maximum, minimum, or intercept if we're talking about the sine function? Where do we begin?
Start at the interval.
Yeah, very nice. Let me see, I just saw something pop up on chat. Very nice. Yeah, you always start at the intercept with the sine function. So we know this left end point is going to be intercept. Then you go to maximum, intercept again, minimum, and you end back up basically where you started out at, intercept. So 0 is going to be intercept. So if we are adding, you know, period divided by 4, where will your next endpoint take you? If you started at 0 with your left endpoint, and then you keep adding period over 4, what will be our next endpoint? Abdul Aziz, very nice, because remember the period for our function is 8. So you're basically taking 8 divided by 4, which is 2, which means once you begin with this left end point, you keep adding that number 2 to get your next, you know, 5 key points. So this will be 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. And if you do this correctly, you should end up at that, you know, right end point from your period interval. Does that make sense? How you break that down? Because, you know, I want to make sure you will be able to replicate this when you're working on homework or, you know, quizzes, exams, whatever might be the case. All right, now let's talk about, you know, completing these ordered pairs. So this is where your amplitude and vertical shift will come into play. Now, obviously, we have no vertical shift because our D value was 0. So all you have is the amplitude. So amplitude is at +1. So using that amplitude, can you tell me what your 5y value should be as you begin from the left and make your way to the right? What your y values are going to be here? Okay, Katie, you've got 0 for the intercept. Very good. Maximum would be at +1. Intercept, you're back at 0. Minimum is at -1 and intercept is at 0. Perfect. So all your intercepts because we are not moving vertically, are going to fall at 0. Maximum is the positive a value, minimum is the negative a value. All righty, perfect. So let's take a look at what this graph will look like. Can we do black and see if that will help us? Nope, it's still purple. Oh well. So since our period here is 8, you're not going to be using pi halves, 3 pi halves like we did with the previous example, because the period actually guides what your x-axis will look like. So since our period, or think about the period interval, is going from 0 to 8, you're actually going to break this down. Of course, we obviously start at 0 over here. So you can see how this guy is going from 2, 4, 6, 8. We'll do the same thing on the negative side. -2, -4, -6, -8. So that gives us our, 2 full periods. Our amplitude is 1. So +1 and -1. And then let's see, we have intercept at 0, 0, +2 and 1, 4 and 0, 6 and -1, 8 and 0. And then, of course, reverse that. So if you are at intercept at 0, 0, and you had maximum at +2, which means at -2, you would be at a minimum. -4 is intercept. -6 would be maximum, which means -8 would be intercept again. And this is what this function will look like. Now this guy is going to look like the phase shift hasn't happened with that pi/4. But if we had to superimpose the basic sine function, you would see that this guy is a little bit more spread out than our sine of x function. Is because the b value for a sine function would be 1, whereas for this function our b value was pi/4. Because if you think about this, pi halves is 1.5, approximately 1.6. So that would be falling, somewhere over here. Pi is 3.14, so that would be somewhere over here. So if you had to superimpose your sine function, we would have intercept here, maximum here, intercept here. So 3pi/4, sorry, 3pi/2 will give us what? 4.7. So it would be here. So let's see. We would actually have a minimum. And then 6.28 would be intercept. So your sine function would actually end up looking something like this. So like I said, it would be a little bit narrower than our sine of pi/4x. So again, you can see how we are using the amplitude, the period, and in this case, we didn't have left or right movement, but what you had was that horizontal. Remember, we called it the horizontal. Was it stretch or shrink? Which in this case, it should be a shrink because you're using pi/4 as your b value. So we had kind of talked about that also last time. So just, different ways of how, kind of like you're seeing right over here in this graph. So you can see how in the gray you have the sine of x function, but then when you have that one in the black is sine of x/2. So you can see how those curves have become a little bit longer. So that's actually the same thing we are noticing in our graph. Our curves had also become a little bit wider, longer horizontally. So that's kind of the effect that happened, because look at how this graph has a period of 4 pi, whereas the original graph only has a period of 2 pi. So that's the same thing with us. You know, the original graph has a period of 2 pi, but ours has 8, which is just a little bit longer than that 6.28 for a 2 pi period. So questions on this example over here. So I honestly cannot insist enough, guys, you know, watch the video lecture and then start working on your homework so you can start practicing with some of these examples over here. All right, I think we are getting into number 58. So this one over here is talking about how the g function is related to the parent function. Your parent function, since we're looking at number 58, and this is a sine function, so of course your parent function in this example would be the sine function again. So they're talking about describe, you know, the sequence of transformations, sketch the graph, and they're talking about use the function notation to write g in terms of f. So we can talk about that. But let's look at what kind of transformations we are noticing in this function.
Did you say we're doing number 58?
58, yeah. So identify each one of those 4 variables, A, B, C, and D. And this one you can see, this example obviously has all of them in there. Okay, let's take a look here. So Scotty, okay, let me make this bigger. All right, there we go. So we've got A equals -1, +1, B equals 2, which seems to be common between all of you. C equals -π², +π², +π², positive. Okay, so most of you have positive, one of you have negative, oops. And then D equals 4, +4, +4, +4, +4. Okay, so it looks like mainly it's the A and the C where I'm seeing a difference in signs, but as far as values go, you said, yeah, you had B equals 4. Most of you have B equals 2, and looks like all of you have D equals 4. So, alrighty, that looks good, but let's take a look and make sure what we've got over here. So with your A value, that is the coefficient in front of your function sine or cosine. So since you do have a negative sign over here, that will go with the A value. So yes, it is going to be -1 on your A value. So basically, remember the idea here is that negative actually implies reflection, but the amplitude itself, because you know we always talk about the amplitude as absolute value. There we go. So for the amplitude, since we always say absolute value of A, you know, that absolute value of -1 will end up becoming +1. So amplitude will be +1, but A value definitely is -1 because of this sign over here. So that looks good, guys. Let's get on to our B value, which is the coefficient in front of the X. So you can see X here has a +2 in front of it. So that +2 will be, the B. So that will help us with the period of this function, which is 2 pi over B, or 2 pi over 2, which of course the 2's will cancel out. So it's actually shrinking your period, right? It's making it smaller, just a pi as the period. And then let's see, C value is, with that bx minus c inside the parentheses, whatever is being added or subtracted from that expression. There we go. Alrighty. So that, of course, as you guys pointed out, is going to be this part over here, the plus pi over 2. So again, guys, remember, since by default you have bx minus c, that means technically our parentheses is going to be 2x minus, and then another minus pi halves. It's these two negatives, which is making this guy a positive. So yes, technically, our C value is going to be -pi over 2. And I know some of you had the negative sign, some of you left it as positive. So please be careful about that. And then your D value is this number in the front, which is being added or subtracted. So technically, if you see in front of that 4, there's not a negative sign, which means 4 is a positive number, and yes, D will equal 4. So if you think about this, like I said, all 4 variables are going to have an effect on your basic sine function. So if you think about this graph is being reflected because you have that negative sign on the 1. This graph is being, the period is changing because of that 2, right? The 2b value, which is changing the period from 2 pi to just pi. So our period is changing. What is the C value -pi halves doing? What direction is your graph moving in with the C? Okay, let me see what you guys have here. Yeah, very nice, guys. The negative tells us we are moving to the left. Great job. So you are moving to the left. You are reflecting. There we go, reflecting, moving left. What else did I say? We have a shift with the, how do I want to write this? We have a shrink, horizontal shrink, because of that b equals 2, because it made our period smaller. And what is that d value of 4 doing, the +4? How is that making our graph move? Perfect. Yeah, it is making our graph move up by 4 units. So your graph is moving up by 4 units. All righty, very nice. Okay, so that was the first part where they were asking us to kind of describe, the transformations. And actually the sequence will happen with the horizontal shrink actually happening first. Then we have the phase shift, and that phase shift. Oh, come on, buddy. And we talk about this when we do the period interval where you have C divided by B. So that will happen next. Then we will talk about reflection, then moving it. Do I move it left first and then upwards? I think so. This one would be the last. So if they want you to put it in a sequence, that's kind of what this would look like. Now the graphing is definitely going to be the interesting part of this, because we have to take all 4 of those into consideration. Oh, what did I do? Let's see, we have x equals 4 minus sine of 2x plus pi halves. A was -1, B was 2, C was negative pi halves, D was 4. We had amplitude. 1 because of that absolute value. Our period for this function came out to be this pi. Let's go ahead and clear this out, and then we'll start calculating our period interval next. So can you tell me what our period interval is going to be? What are you going to do for the period interval? Looking at the previous examples that you've solved at this point.
You're gonna set 2x equal to 0 and then 2x equal to 2 pi and then solve for x on both.
Just 2x equal to 0 and 2x equal to 2 pi?
Wouldn't it be 2x minus pi over 2 equals 0?
Positive pi over 2, because remember it is 2x plus pi over 2. So yeah, keep
Isn't it the
this part the same. So 2x plus pi over 2, so that equal to 0. And for the other one, 2x plus pi over 2 equals 2 pi. Okay, so I'll give you a minute. Go ahead and solve that, and let me see what are the two endpoints you are coming up with for your period interval. So do you have your two endpoints? Okay, delete negative pi over 4, 3 pi over 4, negative pi over 2, 3 pi over 2, pi over 4, 3 pi over 4. negative pi over 4, 3 pi over 4. Okay, Scotty. Okay, so Katie, looks like you are the only one with that 2 in your denominator. Looks like most everybody had 4. Negative pi over 4 and 3 pi over 4 from us. Yeah, okay. Let's take a look at this here. So, of course, ultimately you are trying to get that x by itself. So we can start by moving the negative pi halves first. Then you have 2x, negative pi halves on the other side. So here we will need to divide by 2, but remember dividing by the 2, since you have a fraction on the right hand side, you can also think of it as multiplying both sides by 1/2, if that helps. So, that way the 2 on the bottom and 2 on the top will cancel out, leaving us behind, with that x value. And then when you multiply, you will actually end up with negative pi over 4. Katie, does that help you? Yeah? Okay. So yeah, just be a little careful with these calculations over here. So let's go ahead and simplify this, guys. The same thing, we start by subtracting that negative pi halves. We are left behind with 2x equals, and then, of course, we will need to simplify these. So you're taking 2 pi minus pi halves. Same thing, find a common denominator. That will give you 4 pi minus pi on the top, 2 on the bottom, which will of course simplify into 3 pi halves. So the right hand side will clean up to 3 pi halves, and then same thing, to get rid of that 2, you can multiply both sides by 1/2. The 2's will cancel out on the left hand side. You're left behind with x equals 3 pi over 4. So it looks like that was the most common answer you guys had. There was just a little discrepancy. Some of you had the negative sign on the pi over 4. Some of you did not. So please be careful with those negative signs, because, one tiny switch and, you're looking at the wrong period interval, which means you're looking at the wrong graph. So you are going from negative pi over 4. Come on, buddy. To positive 3 pi over 4. So this will make our one period. And then remember, we have all of these shifts that we need to talk about. So we still have to consider the reflection, moving left, moving up. Of course, we have our phase shift. I'm trying to think, am I missing anything? Okay. Let's see what we end up looking like, and then maybe we'll fix some of these things. We'll make this guy just a little bit longer. Okay, so like we did last time, you want to come up with those 5 key points. Remember, your base function is still a sine function over here. So with our key points, do you start at a maximum, minimum, or intercept for a sine function?
Intercept.
Very nice. Yes, always an intercept with the sine function. So let's do that first. Intercept. Then we do maximum, intercept again. Minimum, intercept. So remember how we had seen last time, once you have your interval over here, then you take your period. Since we will be dividing this into, there we go, period divided by 4. The period for our function is pi. So you are going to be taking each one of these numbers and adding pi over 4, starting with the leftmost endpoint over here. So, of course, this guy will be negative pi over 4 over here. What will be your next x value for the maximum if you're going to keep adding that pi over 4 to each one of these numbers. Pi over 2. Billy and then Abdul Aziz. Oh, come on. Okay, Abdul Aziz, are you sure about those values? Because think about this again. You are at, I'm running out of colors. If you are at negative pi over 4, let's do it here. If I'm at negative pi over 4, if I'm adding positive pi over 4, that's going to give me 0, right? It's not going to give me negative pi over 8. Abdul Aziz, does that make sense? Okay. Okay, and then Jack, I've got your answers up there also. Alrighty, so yeah, if you're going to be, to each one of these numbers, if you're going to keep adding that pi over 4, so this guy will then become 0. And then let me get your answers from your chat over here. So yeah, again, you would be adding pi over 4 to this, so that will actually give you another intercept at positive pi over 4. Then you would be adding pi over 4 to this guy again, and let's see, you had, Jack, you had pi over 8. Are we going to have pi over 8 when we add
Yep.
pi over 4 with pi over 4?
No, you get pi hat over 2.
Yeah, because you are adding, man, I am really running out of colors. Let's do it in red. So look over here. If you add pi over 4 with pi over 4, you can see how they already have a common denominator, right? So that 4 will stay the same, and then you're adding pi plus pi, which will be 2 pi. And then, of course, the pi, the 2 goes into 4 2 times. So this reduces down to pi over 2. So this guy here is actually going to be pi over 2. So be very, very careful. Don't rush through the process because, if any, like I said, any of these numbers come out to be incorrect, you are looking at a very different graph. And then for the last one, you can take pi over 2 and add pi over 4 to it. Or, if you want, you can actually also think of this as 2 pi over 4, and you're adding pi over 4 to it. Or, if you're doing it directly from here, pi over 2 plus pi over 4, it doesn't matter, just find a common denominator, whatever you are comfortable with. So tell me, what will this last intercept value come out to be?
3 pi fourths.
Very nice, 3 pi over 4. And remember what, as I was telling you in the last example, if you do this correctly, your last key point should be this right endpoint from your period interval. So 3 pi over 4, that's what you should have over here. Now, can you tell me what our y coordinates have to be for each one of these ordered pairs over here? Because remember, in this case, you have an amplitude, but you also have a graph that is moving up. So what is going to happen? Okay, so Jack, which one are you putting that 1 on for the first intercept?
Would it be -1 for the first intercept?
All right, let's think about this. Okay, so typically your
It'd be
sine function,
for the
sorry, go ahead.
it'd be 0 for the first intercept.
For the first intercept, okay. Abdulaziz, you also have 0 on that. So remember your sine function would be starting at, 0, 0, if it was just the sine of x function. So we know this guy has moved left. We know this guy has moved up by 4 units. And it has an amplitude of 1. Additionally, it's also being reflective. So a lot of things you have to consider when you are looking at this. Okay, Abdulaziz is
Mr.
changing it to 3. Yes, ma'am.
I'm sorry to interrupt, but I have another class in like 6 minutes.
Oh,
And
yes,
may
sorry.
I be
Yeah, we are going a little over here. Okay, so what I want you to do, guys, I have given you quite a bit of information, and I will post this little, calculation or whatever you want to call it that I have over here. I would like you guys to try and see what your graph should look like. At least try and come up with these ordered pairs to accommodate for the reflection, moving to the left, moving up, what your amplitude is. Try that, and we'll start with the discussion of this example next time, because if you can understand how to do these graphs for sine and cosine, section 1.6 is also graphing for the tangent, cotangent, secant, and cosecant function. So that's the reason why we're taking this long, to get you guys to be comfortable with these graphs over here. So give this example a try. Try to come up with those 5 ordered pairs and try to see a rough sketch of your graph. And then we'll discuss that next time. Finish 1.5, get into 1.6. So any questions before I let you guys go? Okay, keep working on that, and please start your homework for 1.5. Alicia, go ahead.
Oh, I was just gonna say thank you.
Oh, okay, no problem. Thank you, guys. Be careful. Stay safe. And I will see you on Wednesday morning.